In this video, we'll be talking about the integral regarding tangent and cotangent. So, let us start first with the odd exponents regarding it. So, let us start first with the integral of tangent of x. So, first thing you're going to do here is to put tangent in its other form, which is the integral of sine of x over cosine of x. And so, let u here be cosine of x, and the derivative of cosine of x is negative sine of x, and multiply this by dx. So, take the value of dx, put negative sine x to the other side, so this will be du over negative sine of x. So, substitute all these values into this equation. So, this would be the integral of sine of x over cosine of x is equal to u, and dx here is equal to du over negative sine of x. And so, sine of x would cancel each other out, but don't forget there is a negative sign there. So, this would be the integral of du over negative u. Put the negative sign outside the integral. So, this would be negative integral of du over u. Now, this is a logarithmic integral, and the answer for this would be equal to natural log multiplied by the absolute value of u and plus the constant of integration. So, substitute u back into its original form. U here would be equal to cosine of x. So, the final answer would be equal to negative natural log the absolute value of cosine of x plus the constant of integration. Or, you can use this. This would be positive natural log the absolute value of secant x plus c. Either way, these are the two answers for the integral of tangent of x. Make sure to keep note of this because this will be important later on. The integral of tangent to the power 3x. So, when dealing with odd exponents regarding tangent and cotangent, let us first factor out a tangent squared of x. So, this would be the integral of tangent squared x multiplied by tangent x dx. The reason for this is to transform this into its trigonometric identity. So, this would be secant squared of x would be equal to 1 plus tangent squared of x. So, if we want to take the value of tangent squared of x, transpose 1 to the other side. So, you are left with tangent squared of x would be equal to secant squared of x minus 1. And so, substitute this. You will have the integral of secant squared of x minus 1 multiplied by tangent of x dx. And now, multiply tangent of x between on the parentheses. So, this would be the integral of tangent x secant squared x minus tangent of x multiplied by 1 is simply tangent of x, all multiplied by dx. The next step would be to split the integral apart first. So, this would be the integral of tangent x secant squared of x minus, wait, this should be dx minus the integral of tangent x dx. Let me just erase this first. And so, let us focus first on this first part of integral. Let u here in this case be tangent of x. And so, the derivative of tangent of x would be equal to secant squared of x and multiply this by dx. So, dx right here would be equal to du over secant squared of x. And so, substituting these values for this first integral, you would have the integral of u multiplied by secant squared of x multiplied by value of dx, which is du over secant squared of x. And just copy this first. So this would be minus integral of tangent x dx. So you can see here, secant squared of x would cancel. So you are left with the integral of u multiplied by du minus integral of tangent x dx. So first, let's take the integral of u du. Integral of this is simply u squared over 2. This is just simple power rule. And now, the integral of tangent x dx. So, we already had answered this earlier, so I will not resolve this. And so, the answer for this, as I answered earlier, would be equal to negative natural log the absolute value of cosine of x. And don't forget to add the constant of integration. And so, let's substitute u back into its original form, which is tangent of x. So I will just rewrite this in this form, which is 1/2 tangent squared of x plus, because there are two negatives here, natural log the absolute value of cosine of x plus the constant of integration. So this would be the answer for the integral of tangent cube x dx. Or, if you want the other form, it would be 1/2 tangent squared of x minus natural log the absolute value of secant x plus c. Either way, this can be the answer for this integral. Let us continue on with the integral of tangent to the power 5x. So, as usual, let us first factor out a tangent squared of x. So, this would be the integral of tangent squared of x multiplied by tangent cube of x dx. So, transform tangent squared of x with its identity. So, this would be the integral of secant squared of x minus 1 multiplied by tangent cube of x dx. And so, multiply tangent of cube within this with the inside of the parenthesis. So, this would be the integral of tangent cube of x multiplied by secant squared of x minus tangent cube of x dx. So, split the integral apart. So, this would be the integral of tangent cube of x secant squared of x dx minus the integral of tangent cube of x dx. And so, let us focus first on this first integral. Just ignore this first. So let u here once again be tangent of x. Derivative of tangent of x would be equal to secant squared of x. And so value of dx right here would be equal to du over secant squared of x. So substitute all the value. This would be tangent cube of x would be equal to u to the power of 3 multiplied by secant squared of x, and the value of dx would be equal to du over secant squared of x. And copy this. So this would be minus integral of tangent cube of x dx. So the secant squared of x would cancel each other here. And so you are left with the integral of u to the power of 3 du minus the integral of tangent cube of x dx. So as you can see, you can now see why I told you to take note of the answer for the previous problem earlier. Because as you can see here, we have a tangent cube of x which we solved earlier. So let us solve the integral of the first part. So this would be u to the power of 4 over 4. And the integral of tangent cube of x, as we had solved earlier, would be equal to 1/2 tangent squared of x plus the natural log of the absolute value of cosine of x. And don't forget to add the constant of integration. So let us simplify this now. Our final answer. Put u back into its original form. So you will have 1/4 tangent to the power of 4 of x minus 1/2 tangent squared of x minus the natural log of the absolute value of cosine of x plus c. This is the final answer for the integral of tangent 5 of x. Or you can just switch this, or this can be plus natural log of the absolute value of secant of x. Either way, this can be the answer. The integral of tangent to the power 7x. So as usual, let us first factor out 1 tangent squared of x and multiply it by the rest, which is tangent to the power 5x. And so transform tangent squared of x with its identity here, which would be secant squared of x minus 1 multiplied by tangent to the power 5x. And so multiply tangent to the power 5 of x of this. So this would be the integral of tangent to the power 5 multiplied by secant squared of x minus tangent to the power 5x dx. So as you can see now, you can recognize the pattern that I am doing here. And so split the integral apart. So this would be the integral of tangent to the power 5 of x secant squared of x dx minus the integral of tangent to the power 5 of x dx. So focus on the first part once again. Let u here be tangent once again. Derivative of tangent of x would be equal to secant squared x multiplied by dx. So value of dx would be equal to du over secant squared of x. So this would be the integral of u to the power of fifth multiplied by secant squared of x multiplied by value of dx, which would be equal to du over secant squared of x, and copy the rest, which is minus tangent integral of tangent of 5 dx. And so the secant here would cancel each other out. You are left with the integral of u to the power of fifth of du minus the integral of tangent to the power of fifth x of dx. So first here, take the integral of u to the power of 5, which is u to the power of 6 over 6. And take the integral of tangent to the power of 5 of x, as we had answered earlier. The answer is equal to 1/4 of tangent to the power 4 of x minus 1/2 multiplied by tangent squared of x minus natural log the absolute value of cosine of x plus c. And so, put u back into its original form. So this would be 1 over 6. U here is tangent to the power 6 of x. And distribute the negative sign amongst the parentheses, or the bracket minus 1/4 tangent to the power 4x plus 1/2 tangent squared of x plus the natural log of the absolute value of cosine of x plus the constant of integration. So this is the final answer regarding the integral of tangent to the power 7 of x. Or you can replace this with negative natural log of the absolute value of secant x. Let us now start with the integral of cotangent x. I will not be solving the tangent to the power of 9x because it is basically the same steps, but it's just tedious to work with. So, without further ado, let us start with this. So, put cotangent of x into its other form, which is cosine of x over sine of x dx. This is basically the inverse of tangent, so it is reversed. And so, let u here in this case be sine of x. And so, the derivative of sine of x is cosine of x, and multiply this by dx. Value of dx right here now would be equal to du over cosine of x. So this would be the integral of cosine of x over u, and multiply this by value of dx, which is du over cosine of x. This will cancel. So you are left with the integral of du over u. And so the integral of du over u is simply natural log the absolute value of u plus c. So substitute u, which is sine of x. So this would be natural log of the absolute value of sine of x plus c. So this is the answer for the integral of cotangent of x. Or, if you want to, this is also the same equivalent, which is negative natural log of secant x. Let us continue on with the integral of cotangent cube of x. So it's the same as the rules of tangent earlier because they had an odd exponent. So factor out a cotangent squared of first. And so let us figure out the value of cotangent squared of x on its trigonometric identity. So this is cosecant squared of x would be equal to 1 plus cotangent squared of x. So if you want to take the value of cotangent squared of x, transpose 1 to the other side. So it would be equal to cosecant squared of x minus 1. So substitute it. So this would be cosecant squared of x minus 1 multiplied by cotangent x of dx. So multiply cotangent amongst the parentheses. So this would be the integral of cotangent of x multiplied by cosecant squared of x minus cotangent of x of dx. Split the integral apart, so you would have this value. And so let us focus first on the first part of the integral. So let u here in this case be cotangent of x. And so the derivative of cotangent of x would be equal to negative cosecant squared of x and multiply this by dx. So the value of dx right here would be equal to du over negative cosecant squared of x. So substitute the values. You would have the integral of u multiplied by cosecant squared of x multiplied by value of dx, which is du over negative cosecant squared of x, and copy the rest. Cosecant squared of x would cancel each other out, and you can put this negative sign outside the integral. So you are left with negative integral of u multiplied by du minus integral of cotangent x dx. And so the integral of u du would be equal to u squared over 2, and the integral of cotangent of x, we had solved this earlier, which is equal to the natural log multiplied by the absolute value of sine of x plus the constant of integration. And so put u back into its original form, so you are left with negative 1/2. U here is cotangent of x, cotangent squared of x, minus natural log of the absolute value of sine of x plus constant of integration. The integral of cotangent to the power 5x. So, once again, factor out 1 cotangent squared multiplied by cotangent cube of x. So, put cotangent squared of x into its transformative identity, which is cosecant squared of x minus 1 multiplied by cotangent cube of x dx. So, distribute cotangent cube of x. And split the integral apart. And so, let us focus first on the first part once again. Let u here be cotangent of x. Derivative of cotangent of x would be equal to negative cosecant squared of x multiplied by dx. Dx right here would be equal to du over negative cosecant squared of x. So substitute the values. You would have the integral of u to the power of 3 multiplied by cosecant squared of x multiplied by dx, which is du over negative cosecant squared of x, and copy the rest. Cosecant squared of x would cancel each other out and put the negative outside the integral. So you are left with negative integral of u to the power of 3 du minus the integral of cotangent cube of x. The integral of u to the power of 3 would be equal to u to the power of 4 over 4. And the integral of cotangent to the power of 3, as we had solved earlier once again, would be equal to negative 1/2 cotangent squared of x minus the natural log of the absolute value of sine of x plus c. And so the final answer would be equal to negative 1 over 4 of cotangent to the power 4x plus 1/2 cotangent squared of x plus the natural log of the absolute value of sine of x plus the constant of integration. Lastly, we have the integral of cotangent to the power 7 of x. Once again, factor out a cotangent squared of x. And transform this into its identity, which would be cosecant squared of x minus 1 multiplied by cotangent to the power of 5x. And distribute cotangent 5x and split the integral apart. And so, focusing on the first part of the integral, let u here again be cotangent of x. So, derivative of cotangent of x would be equal to negative cosecant squared of x dx. Dx right here would be equal to du over negative cosecant squared of x. Substitute the value. So, this would be the integral of u to the power of 5th multiplied by cosecant squared of x multiplied by du over negative cosecant squared of x, and copy the rest. Cosecant squared of x would cancel each other out and put the negative sign outside the integral. So you are left with negative integral of u to the power of 5th of du minus integral of cotangent to the power of 5x dx. So this would be negative u to the power of 6 over 6 minus the integral of cotangent to the power of 5x. So this would be, the integral of cotangent to the power of 5 of x, it would be equal to negative 1/4 cotangent to the power 4x plus 1/2 cotangent squared of x plus natural log absolute value of sine x and plus the constant of integration. And so the final answer would be equal to negative 1/6 cotangent to the power 6x plus 1/4 cotangent to the power 4x minus 1/2 cotangent to the power of 2x minus natural log absolute value of sine of x plus c. Let us now start with the even exponents regarding tangent and cotangent. It has basically the same rule, but for convenience sake, I just separated even and odd exponent. So, remember that tangent squared of x is equal to secant squared x minus 1 according to the trigonometric identity. So, there is no need to factor out anything here because it is solely tangent squared of x. So it would be the integral of secant squared x minus 1 and split the integral apart. So you have integral of secant squared x dx. Since this is negative, it would be minus the integral of simply dx. The integral of secant squared of x, there is no general solution here, but according to the derivative rule, the derivative of tangent of x is equal to secant squared of x. So by reverse, if you take the integral of secant squared of x, the answer here would be equal to tangent of x. So the answer here would be simply tangent x, and the derivative of dx is simply x. And don't forget to add the constant of integration. Moving on to the integral of tangent to the power 4x. So first, factor out 1 tangent squared x. And transform it according to its identity. And so, distribute tangent squared of x to this parenthesis. So this would be the integral of tangent squared x secant squared x minus tangent squared x. And so, split the integral apart. So you have this. So let us focus on the first part of the integral. Let u here be tangent of x. The derivative of tangent of x is secant squared x, and multiply this by dx. So dx right here would be equal to du over secant squared of x. So substitute it. So you have the integral of u squared multiplied by secant squared of x and multiply this by value of dx, which is du over secant squared of x, and copy the rest. And so the secant squared of x would cancel. So you are left with the integral of u squared du minus integral of tangent squared x So take the integral of u to the power of 2, which is u to the power of 3 over 3. And take the integral of tangent squared x, which we solved earlier. The answer for this would be equal to negative, positive tangent of x minus x. And don't forget to add the constant of integration. So the final answer here, firstly, substitute u back into its original form. So it would be 1/3 tangent cube of x minus tangent x plus c. Tangent to the power 6x. So, factor out 1 tangent squared of x. And transform tangent squared of x according to its identity. And distribute tangent to the power for x inside the parenthesis. And so, let us focus on the first part. So, u here be tangent x. Derivative of tangent x is secant squared of x dx. And so, dx right here would be equal to du over secant squared of x. By substitution, you would have the integral of u to the power of 4 multiplied by secant squared x multiplied by dx, which is du over secant squared x, and copy the rest. The secant squared x would cancel. So you are left with the integral of u to the power of 4 du minus integral of tangent to the power of 4 of x. Integral of u to the power of 4 would be u to the power of 5 over 5. And the integral of tangent to the power of 4 is what we solved earlier, which is 1/3 tangent cube of x minus tangent of x plus x plus the constant of integration. And so the final answer would be 1/5 tangent to the power of 5x minus 1/3 tangent cube of x plus tangent of x minus x plus c. Let us move on with the integral of cotangent squared x. Keep in mind that cotangent squared of x is equal to cosecant squared of x minus 1. So this should be integral of cosecant squared x minus 1 dx, and we can split the integral apart. And so, the integral of cosecant squared x, this is the same case as the secant squared x earlier, wherein we can just find the integral by the reverse. Keep in mind that cotangent, or the integral of cotangent of x, is equal to negative cosecant squared of x. And so, if we take the integral of this, it is equal to cotangent of x. But since what we have here is a positive cosecant squared of x, but since this is negative, so the integral of cosecant squared x is simply negative cotangent x, and take the integral of dx, which is x plus c. The integral of cotangent to the power of 4. So, factor out a cotangent squared. And transform it according to its identity. And distribute cotangent squared amongst the parentheses. And split the integral apart. So this should be like this. Focus on the first part. Let u here be cotangent of x. The derivative of cotangent of x is negative cosecant squared of x, and multiply this by dx. So the value of dx right here would be equal to du over negative cosecant squared of x. Substitute it, so you would have the integral of u squared multiplied by cosecant squared of x multiplied by value of dx, which is du over negative cosecant squared of x, and copy the rest. Cosecant squared x will cancel, and put the negative outside the integral. So what you have here is negative integral of u squared du minus integral of cotangent squared of x dx. So take the integral. This would be negative u to the power of 3 over 3 minus the integral of cotangent squared of x, as we had solved earlier. It is equal to negative cotangent of x minus x. And don't forget to add plus c. So the final answer would be equal to negative 1/3. U here is cotangent. And since this is u cube, it would be cotangent cube of x plus cotangent of x plus x plus c. Lastly, the integral of cotangent to the power 6x. So, factor out 1 cotangent squared. and transform it according to its identity. And distribute cotangent to the power 4x. And split the integral apart. And so, focusing on the first part, let u here be cotangent of x. Derivative of cotangent of x would be equal to cosecant squared of x multiplied by dx. So dx right here would be equal to du over, wait, this should be negative cosecant squared of x. And so by substitution, what we have here is the integral of u to the power of 4 multiplied by cosecant squared x multiplied by dx, which is du over negative cosecant squared x. And copy the rest. The cosecant will cancel and the negative here would go outside. So what we have here left is negative the integral of u to the power of 4 du minus the integral of cotangent to the power of 4 of dx. Integral of this would be equal to negative u to the power of 5 over 5, and the integral of cotangent to the power 4 of x. We solved it earlier, which is equal to negative 1/3 cotangent cube of x plus cotangent of x plus x, and don't forget to add plus c. So the final answer here, substitute u back first, so this would be negative 1/5 cotangent to the power of 5 x plus 1/3 cotangent cube of x minus cotangent x minus x plus c. This is the final answer.